Welcome to Algebra 1, Chapter 5, Section 6, Parallel and Perpendicular Lines. And review. Now, a reciprocal is the number. Now, a reciprocal of a number is what you can multiply it to get the product of 1. So the product, the answer of a number and its reciprocal is 1. Looking at question 2, which one of these, when multiplied together, would equal 1? This one would, and there's one other one. This one would. Our vocabulary word is parallel. Lines that are parallel are lines in the same plane, but they never intersect. Here are the symbols for parallel lines. It's two vertical lines next to each other. So in this case, line, this is the symbol for line, AB is parallel to line CD. Looking at the vocabulary at the bottom, the railroad tracks in picture A are parallel or perpendicular? Well, think about it. Would they ever cross? So they are parallel. The window bars in picture B that do not meet, so we're talking about these. Those would be, correct, parallel. And picture C, in this case, they will meet, they cross, create 4 right angles, so they are perpendicular. Parallel lines are lines in the same plane that never intersect. Any two non-vertical lines that are parallel have the same slope. So we can tell what a parallel line is if it has the same slope as another line. And all vertical lines are parallel to each other, even though their slopes are undefined. Non-vertical lines are parallel if they have the same slope and different y-intercepts. Now, if they have the same y-intercept, they're actually the same line. The line shares the same slope and the same y-intercept, it's the same line. But if it's the same slope and different y-intercepts, they're parallel. And again, vertical lines are parallel if they have different x-intercepts. So we're going to draw a line from the equations in column A to the parallel equation in column B. So remember, we're looking for the same slope. Well, this one has a slope of 2. So over in column B, which one has a slope of 2? That is correct. Now, do they have different y-intercepts? Yes, they do. One has a positive 4, one has a negative 4. Okay? The second equation has a slope of 1/3. Which equation in column B has a slope of 1/3? Correct. And again, we have different y-intercepts. Now, in column A, we have x equals 3. That means the slope is undefined. So it's parallel to the undefined slope in column B. At problem 1, we see we want to create a line that passes through -3, -1, and is parallel to the line that uses the equation y equals 2x plus 3y. Well, y equals 2x plus 3y is a line in slope-intercept form. So we realize from this that our slope is 2. That means the slope of any line parallel to this equation will also be 2, but just will have a different y-intercept. So we can use a point-slope form since we know the point and we know the slope. Now once we do that, we can go ahead and solve this for the y so that we will then be in the slope-intercept form. Another example of the same type of problem. As you can see here, we have an equation of a line. And we want to make a line parallel to that equation, but going through point 12,5. So the first thing we need to do is find the slope of that line. And the slope is 2/3. And we know that because this line is in the form y equals mx plus b, which is also known as a slope-intercept form. And so our m is 2/3. Now we take our slope and we take our point and we put it in point slope form. Then we do our distributive property. And we solve for y. So y is equal to 2/3 x minus 3. Notice that we have the same slope, so our lines are parallel. When we talk about parallel lines, it only makes common sense to talk about perpendicular lines. Remember that two lines are perpendicular if they intersect to form right angles. If two lines are perpendicular, then their slopes are opposite reciprocals. Any horizontal and vertical lines are perpendicular. The big one to remember here are if two lines are perpendicular, their slopes are opposite reciprocals. Two non-vertical lines are perpendicular if the product of their slopes is -1. Two numbers whose product is -1 is called opposite reciprocals. A vertical line and a horizontal line are also perpendicular. So if a slope of a line is 2, what is the slope of a line perpendicular to that line? Which means that these form right angles. You're correct. It's -1/2. 1/2 is the reciprocal, and -1/2 is the opposite reciprocal. In problem 2, we're being asked if the graphs of y equals 3/4 x plus 7 is parallel, perpendicular, or neither to the graph of 4x minus 3y equals 9. Well, to determine this, we need to put both graphs into slope-intercept form. So the first one is already there. We just need to do the second one. This is the first equation. It is already in slope-intercept form, and we know the slope is 3/4. The second equation we need to put into slope-intercept form. So I need to isolate the y. So the first thing I'm going to do is to subtract 4x from both sides. So I get -3y equals 9 minus 4x. Now to isolate the y, I'm going to divide both sides by 3. This will make a y on the left, and then I need to distribute my division here. So -9 divided by -3 is -3. -4 divided by, -4x divided by -3. It's going to be a positive 4/3 x. And then I went ahead and rearranged this so it was in slope-intercept form. Now, as you can tell, my slope on this side is 4/3. So is the slope the negative reciprocal? As you can see, it's reciprocal, but it's not the negative. Since the slopes are not the opposite reciprocals, nor are they the same, the answer is neither. The slopes are the reciprocals, but since they're not the negative reciprocals, the lines are not perpendicular. Here's another example to look at. In the first line, we have 4y equals -5x plus 12. And to isolate the y, we're going to divide both sides by 4. So y is going to equal, distribute it here, you get -5/4 x, and distribute it here, you'll get plus 3. Now the second equation is already in slope-intercept form, and so we can see here that their slope is 4/5. While on our first line, our slope was -5/4. Since these are the opposite reciprocal, or the negative reciprocal, the lines are perpendicular. In problem 3, we're asked to create an equation of a line that will pass through 1/8, but is perpendicular to the graph of y equals 2x plus 1. To determine that, we need to first remember that a perpendicular line is a line who has the opposite reciprocal of the original line's slope. Well, this slope here is m equals 2. So the slope of the given line is 2. Its opposite reciprocal is negative 1/2. And I know that because 2 times negative 1/2 equals 1. So the slope of the perpendicular line is negative 1/2. Well, now I have a slope, and I have a point, and I'm able to use the point slope form to create a line. So y minus y sub 1, which is 8, equals m, which is negative 1/2, times x minus x sub 1, which is 1. Distribute. Solve for y by adding 8 to both sides. And y equals negative 1/2 x plus 8.5. Now that makes sense because this slope is negative 1/2, which is the reciprocal of this slope. So my lines are perpendicular. We're going to write an equation in slope-intercept form for a line that passes through 2, 4 and is perpendicular to y equals 1/3 x minus 1. Now y equals 1/3 x is in the form of a slope-intercept. So I can tell you that our slope is 1/3. So my perpendicular must have the opposite reciprocal to that. So my perpendicular line must have a slope of negative, because the other one was positive, reciprocal 3/1, or negative 3. So I'm going to create a line using a point slope formula, because I have a point right here, and I have a slope right here, so I can create a line. So y minus 4 equals negative 3 times x minus 2. Distribute. Get y by itself by adding 4 to both sides, and my equation is y equals negative 3x plus 10. So now I'm going to check myself. My slope is negative 3. The reciprocal of 3 is 1/3, and the opposite reciprocal of negative 3 is positive 1/3. So this works. So my equations are perpendicular. Here we have a real-world problem. This architect is using software to design a ceiling. The architect needs to enter an equation that represents a new beam. The new beam will be parallel to the existing beam shown on the graph, and the new beam will pass through the corner at 0, 10. So what is the equation in slope-intercept form that represents the new beam? The first thing I need to do is to find 2 points. So I'm going to use the point, it's right here, 6, 4, and I'm going to use the point 3, 6. So 3, 6, and 6, 4 both look like good points. I'm going to make this x sub 1, y sub 1, x sub 2, y sub 2. My equation to find a slope will be my y sub 2 minus my y sub 1 over my x sub 2 minus my x sub 1, and so I will get a negative 2/3. Now, in order for the new beam to be parallel to the existing beam, the slope should be the same. So I need to find an equation of a line that would be parallel but pass through 0, 10. So I need to use the slope point formula. Y minus y sub 1 equals m times x minus x sub 1. So y minus 10 equals negative 2/3 times x minus 0. So y minus 10 equals negative 2/3 x. I'm going to add 10 to both sides. So I have y equals negative 2/3 x plus 10. And that's the equation for my new line. I believe all we have left is the lesson check and then the math success, where you can check to make sure you understand the current definitions and can gauge where you're at. Complete those, and I'll see you in class tomorrow. Bring any questions you may have with you.